Hello friends, my name is Amit. Welcome to NDT and Quality channel. In today's video we will continue in the series of PAUT. Till now we have made total 3 videos in it. In 3 parts we have already covered that. If we talk about the first part, then how does constructive-destructive interference and beam steering work on its basis, and in the second video, we saw how the element in the probe works, its pitch, what is the gap, what is acre, etc. In the third part, we saw about the steering angle and how it works. Different elements have different number of elements, so how will it be different? And about acre, we saw that how effective acre works, that too depends on the number of elements, so if you have not seen all these videos, then do watch this also. This is the fourth part of our PAUT today, so in the fourth part, we will see about near field. In PAUT, if you have to focus, then near field is a very important factor, right near phi or near zone as you call it. So I will also tell you the calculation of near phi. So on the basis of near phi, focusing in PAUT is decided that how you will get focus, and in this we will also discuss one more thing about active nature, the active appraiser, which is your. It depends on the element and how the effect actually occurs in PAUT due to active appearance. We will cover in also included video examples in it, so you will get more idea about how it works. So if you have not subscribed our channel till now, then definitely subscribe the channel and share this video with your friends and colleagues. And also by using the join feature, you can take membership of the channel. So I have made many. Remember, you can use it and support me financially. So see this right here. So in the first video, we had talked about constructive-destructive interference. In the second video, we had discussed the elements, etc., and the prop, how it works, and the frequency, etc. We had also discussed about the element size. What is the number of elements? In the right and last video, we had seen about effective appraiser. Now yes, here 16 elements are complete. What a pulsing is done, or 4-element pulsing is done. This we discussed. Okay, and lastly, how does the element width affect the steering? We had also seen this in the last video. I had told you that I will show you an animation of beam steering. So let's see this first, later. The video will continue. Okay, so I have this OP Tech company, this animation, etc. is shown very well in it, so let me show you. See this beam, which is there right here. Now as the time delay is given differently, this beam will be steered right, so see here, this is the condition. Suppose this is the direction of the beam, you're right. In this case, you have given the crystal here, meaning this first crystal has been given the least time delay. After that, gradually you have given more time delay, right? So if you have given the time delay in this way, then it will be found here also. Me play it once again. See right here, gradually the time delay gets reduced. See, the beam will be steered in this direction from here, right? Just like you have gone to the doctor. If you have a pregnant lady, they do sonography at and that also you will get to see a rotating display like this from here. Right, in such a con shape, and there, whatever test, etc. is done for your baby, right? Sonography, etc. is visible in it. Okay, any of you, sonography of the stomach. If we do sonography, then in that case such a display is seen. That is also a type of beam steering, right? So UT, which is the earlier time, which first came in the medical feed only, later it is used in us. So here in the beam steering, it is such that from here on, this area is steering completely to the right, meaning this covering the entire area. For this, it has to give different time delay to all the elements. First of all, here the time delay was more, and later it gradually reduced in this last one. Got the highest time delay right, so everything is done electronically, and on the basis of that you get time delay, and you also get different scanning angles. And see right in this, if you see the third part of focusing, we will see later, then the focusing is also the same. The time delay in this is more, right? And if you go to this place later, it will reduce, right? Call it quadratic and square time delay. is called like this, okay, and there's focal point, that too if you want to make it more or less, then for that also you can give time delay in this way, right? So this is the requirement for beam focusing also, like suppose till here your near phi is the third of near phi. This is what we will cover in the video, right? So till near phi, when anywhere, can focus the beam, right? So anywhere, you have this entire area in this area. You have to focus the beam anywhere in it. Then in that case, you will have to give different time delays to the elements, like here. If you want to focus it all, then this element is given the maximum time delay, right? So see again I play the animation, see this, right? So from here onwards, you can take the focal point anywhere, okay, as you will increase this time. You will get the focal point on the center element on the top side. This is called beam focusing, so the size of the focal point is also defined by you. You can also do that. The size of the focal spot will also change and the location will also change. Okay, so this is how it works. Now let's see further in the video. Okay, so this is the element we covered in the video. Now we will see about the near field. Near field is very important in the case of PT. You get the length of the near field, then after that whatever length you get, you can focus the beam anywhere beyond that. So see the near field length, the length, near the distance, from the probe the device emitting sound wave and the sound wave are still focusing and converging, right? So this is the whole fund of near phi. We have covered it in great detail in conventional UT. If you do not know, then you can go to conventional UT and watch it. You will find a lot of videos in the playlist of the channel. So here the sound till the length of near phi is converging. After that it diverges, right? Like let's say the sound is like this, okay. So it diverges from here. So this is the length. This is your near field, right? This is the near field, and you will get the length of this near field from the formula. This is its simple calculation. We will see further. So this is the beam anywhere because the beam is converging till here. So the sound has to be focused somewhere here, 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 or here. So for that you will have to give different time delay, simple after this distance the sound beam starts spreading out, right? So after that the beam will start spreading out, right? So the beam will start spreading out, right? So you can see here. In this case the beam has started spreading from here, means the length of the near field is completed. After that the beam will spread, so the near field formula is not it. Is quite simple, which is the same as used in conventional. The formula to be used is rat, so script by folda. In this you will put lam e by, here you will put rack here. Instead of lam l, c is written. C means velocity, c ba f, right? C means speed of the sound, or velocity of sound. If you keep this, then you will get the length of the near phi. The rest is the diameter of the prop, is the frequency, and the lambda is the wavelength lmx. Okay, so in this way you will get the near phi. And in near field you can focus the beam anywhere. Remember that after near field you will not be able to focus the beam, always. Keep in mind that after near field the beam will not be focused. Now let's talk about active enhancer. This is also a very important factor. Now we had talked about effective enhancer in the last video, so this is the difference between effective enhancer and active enhancer. So, see, imagine we have 16 element proof. Each element has a width of mm, right? What is the width of the element? What is the width of the element? Which is 2 mm. We used to say right by saying right. We had seen the figure of the element in the second video. The total width of active element becomes the width of the element. So active element means the number of elements in the width, right? In this, the gap that remains in the middle, we have minus it, like here I am telling you. Tell me, we had seen this. Right, so look in this. This is the width of the element, which is written E. Is the width of the element, okay, and into number of elements means the number of elements, 2, 4, 5, 6 to 8. In this case, A element, right, so 8. This is the width of element into. We'll show you its active aperture. So here the gap is this gap. This gap has been minus it. Okay. Gap is not to be considered. If you talk about active aperture, then okay, so look at the example here. What we have taken here is a probe with 16 elements, and the width of it is the width of the element is 2 am. So you will get an active aperture of 3.2 am. Right. This is the active aperture. So if you wanted a larger active aperture than 6.4 am, you would need 32 elements. Right. So suppose you use a 32 element probe. In that case, you will get an active aperture of 6.4. You will get an active aperture of 6.4 am. So the aperture is more. What will happen in this case? We had covered in the previous video. You will get more focus. Steering of wide beam. The angle is there. It will be less, and focusing will also get more focus. The intensity will be good. Okay, so here the active focus works like this. This is the gap between the elements. You subtract it. A is simple. So why is it important? Right? Why is the active focus important? Take an example at 3.2 and at 3. How much m, and if there are 32 elements, in that case you get 6.4 mm, right? So compare these two simply. So let's say the smaller aperture is 3.2 am, which makes the sound beam spread out more quickly. So in this case the sound beam will spread more quickly, meaning it doesn't penetrate ST and can't focus the energy well, right? So here it is smaller aperture, so its meaning is that the spreading will be more, right? Spread you will get more. We saw this in that video yesterday. Also, you will not be able to do deep focus, which means you will not be able to penetrate much. It limits its sensitivity and how much area you can cover. Right, so in this case, the sensitivity will reduce and the area you cover will also reduce because you will not get much penetration. Okay, and the area too. Yes, much area. You will not be able to cover much because it has less aperture, so at the time where you have placed the probe, you will be able to cover only that much area, while the larger aperture is 6.4 mm. Right, this helps sound focus is better. You will get more focusing, right? Means you will be able to focus far in it, along with deeper penetration and more process. Testing penetration, you will also get good. It gives better resolution and steering of the sound. Okay, and the resolution will also be good because the intensity of the beam will be good. It is larger aperture. There are more elements. Okay, so in this case, you will get very good resolution. And penetration will also be good. You will get deep penetration. Okay, so active archer, which is very important in you. Our empty archer, affected archer, you subtract the gap from it, then you get active archer. You will see that if you do more or less, then the advantage of both of them is the limitation is the same, right? But active archer is more effective. What is the difference in the upper? That is empty. Have to keep it in mind. Okay, so beam spread and steering. So 1. You emit sound from a phase. Q. Sound beam spread out over time. Right. If the sound beam spread, it will spread. When will it spread? When your near zone is complete. After that, the sound beam will spread. You can control where the beam is focused by using to steer it in different direction. Right. So steer it as it is. You steer in different direction. What I have shown in the animation is that you are able to steer it in different directions. The smaller the aperture, the more spread out the beam is, and the harder it is to focus the beam deep into the material, meaning the aperture is less. In that case, the beam will be more spread. Okay, in this also we saw that. In the case of smaller aperture, you get to see more spread out, and if you have to focus somewhere, it is very difficult, and in this you will also not get penetration if it is smaller aperture. Then right, so this is the limitation, right? Like here is an example given. Okay, like width of element is 2 mm. If total aperture is considered, then there is a probe of 16 elements. Then in this case, how much active aperture will you get? It will be 3.2 mm. Right here, it is not total, but active aperture will be called this. Right, so active aperture 3.2 A will be found if the sound velocity in the material is 1,500 meters per second, frequency 5 megahertz. We can calculate near field. So first of all, LOT F, so the value of LOTA was found to be 3A, and we had seen the formula of near feed DS by 4. LOTA, so in this you will keep the value sub, so 8.53A, the answer will be right. 8P5 S miss the sound beam is still focusing up to distance of 8.53 mm for the prom rat. So here the sound beam is how much it will be focused till where it will be focused 8.53 mm till after it starts spreading out. After that it will start spreading, right? So now for what did we take it? This is the etcher here. It is 3.2 mm. It was taken for this, right? But suppose I give you the calculation on 1 and y, you do it according to your own and give me the answer in the comment box. Suppose here instead of 16 elements, you take a probe of 32 elements, right? 32 element probe. So in that case you will do this complete calculation. First of all, find out what is the total element. After that, you have to put it here, right? And after that, you have to find the length of the near fill. So you will get the idea that the length of the near fill will be more in this. The right will be very much. So in this case, the length of the near fill is more. In the case of 32 elements, the near fill is more. It means that you can find it anywhere in the particular area. Whatever you can do focusing, it will be more. Okay, so you tell me the answer to this. Do write in the comment box, do you get the answer? Okay, so in this way, this near field works in focusing, etc. also works in this way for active nature. We have covered this in the video. Now in the next video, we will see in more detail about focusing, how focusing works and what is focal length, etc. I hope you have understood this video completely. You must be enjoying this series. If you are going to give PCN PAUT exam, then this video series will be very important for you, right? Which is the third part of PCN examination. A lot of questions come from it, right? So let's meet again in the next video. If you have any confusion, doubt in this video, then you can ask in the comment box. Okay, thank you.